All right, folks, so here is a video that that explains number 6, 7, 8, 9 from week 21 Wednesday. Let's start with 6. Let's go straight down the list. Okay, so original problem is in black over here, and I know it looks a little bit messy here, but let me explain it. Okay, so right now we have y times the root 1 minus x squared dy over dx equals to x times the square root of 1 minus y squared times dx. What we're going to do is multiply both sides by dx, which makes the dx move over here. We're going to get all the y's together and all the x's together. So let's get all the y's together. We're going to divide both sides by 1 minus y squared. So this moves over here. We're going to divide both sides by 1 minus x squared. So 1 minus x squared is inside the root, moves over here. So as of right now, we get these blue highlights. Okay, so we go from here to these blue highlights right here. Okay, now the blue highlights over here, okay, because root 1 minus y squared is on the denominator, and we're going to just write it as to the power of negative 1/2. Same thing with this. We're going to rewrite it as to the power of negative 1/2. Okay, and we're going to do some u substitution over here. So we're going to set u equal to 1 minus y squared. Proceed as usual, take the derivative of both sides, divide both sides by negative 2y to isolate dy. And then, so this got copied over here, okay, and the pink, this 1 minus y squared gets substituted with a u, hence this u here, okay, and then the dy gets substituted with, okay, let me throw in another highlight over here, the dy gets substituted with du over negative 2y, okay, and I should do the pink over here again because it got substituted with the u, all right. And then we got the y that carried down over here, okay? And then, so we got these substitutions going on. The y's cancel. You're left with negative 2 on the bottom, okay? And when you take the antiderivative of u to the power of negative 1/2, you get this. The 2's cancel, and you're left with a negative. And then we substitute back in the u right over here, okay? We substitute that back in with 1 minus y squared. So now I just wanted to basically explain this is what we got after the u substitution, and that matches up here. And by the same exact steps, you get this right here, okay? And this should really say plus c1. This should really say plus c sub 2. And when you subtract the c's, it's still a constant. So we just move the c's over here. You just get one big c over here. Now we plug in the initial condition. The 0, okay, the 0 gets plugged in over here, okay, the 1 gets plugged in over here, okay, and 1 squared is 1, 1 minus 1 is 0, 0 to the power of 1/2 is 0, negative 0, 0, so that's what this 0 is about, okay. 0 gets plugged in here, 0 squared is 0, 1 minus 0 is 1, 1 to the power of 1/2 is 1, and you have a negative, so negative 1, all right. This becomes negative 1. And then we get the c just carried down. Isolate c, and you get c equals to 1. And you just plug that in over, here. Okay. Let's see how they. Oh, I see. Yeah, so they plug that in over here and just multiplied everything by negative 1, which makes it. This turns positive, this turns positive, this turns into negative 1. Okay, that's number 6, folks. If you need to slow down or rewind, go ahead and do so. Let's talk about number 7 over here, okay? Number 7, they basically, the first step, obviously, multiply both sides by dv, and you get to the second step over here. Now, you do when you take the antiderivative of this side, we've done this a million times, you get ln, okay? And don't forget to throw in the absolute value because, well, you already know why we've done that a million times. Now we're going to do a u substitution. We're going to set u equal to v squared, and this is what we produce right here. And then, and let me throw in an orange over here. And so anywhere you see d after taking the derivative of both sides and isolating for dv, you get this. So anywhere you see dv, you put that. So dv gets replaced with this. Okay. Whoops, let me highlight that a little bit better. dv gets replaced with that. And And let's see. Oh, okay. And so basically, I literally just I copied this right here, okay? And okay, yeah, the v squared got substituted with the u. That's what we got here. The dv got substituted with du over 2v. Now the v just got carried down here, and then it cancels with this v. And then the antiderivative sign is negative cosine. And then you got the 1/2. This is 2 on the bottom, invisible 1 on the top. And then we just rearrange some things. Okay, the negative we just put in front of the 1/2. And then anywhere you see a u, you put a v squared, and this is what you get. Okay, and that is why this right here matches with what you got here. Okay, all right. And remember, this should say, ideally this would say plus c sub 1, or this should say plus c sub 1, this should say plus c sub 2, subtract it, and this just becomes, I would have wrote it as just a big C. Okay, now how did they get from here to here? Okay, this is just property of logs, folks. So really we're going to do, so ln, I'm going to rewrite it as log base E. Okay, and we're going to do circle of logs. I call it circle of logs. E to the power of this thing equals to u. Okay, so that's what we got here. All right, so again, we're going to rewrite ln, a natural log, as log base E, and do circle of logs. E to the power of this crap equals to u. The reason why we don't need the absolute values is because e to the power of anything, positive or negative, is still going to be positive. So we don't need the absolute value here. That would be a little bit repetitive. Okay, now when you are adding with exponents, okay, when you're adding with exponents, you can separate it out into two bases, okay? You can separate into two bases with multiplying. All I'm trying to say is this: 2, okay, to the power of 2 plus 3 is going to equal to 2 to the power of 2 times 2 to the power of 3. And that's what they did to get from this line to this line over here, okay? And then this is just one big fat constant. They're just going to move up front. Hence, okay, hence we're going to get from this line right here to this line right here, okay? And now we just plug in the initial condition. The initial condition was 0, 1. So, so we get cosine of 0 squared, which is 0. And so cosine of 0 is going to be 1. Okay, so you get negative 1 over 2, hence this right here. Okay. Yeah, so this whole thing becomes e to the power of negative 1 over 2, and this is 1, and then you divide both sides by e to the power of negative 1 over 2, okay, and you divide it over here also, okay, and that's how you isolate c. And so c is going to equal to 1 over e to the power of negative 1 over 2, which is the same thing as e to the power of 1 over 2, okay, and then you just plug that back in. Okay, now you just plug that back in over here. So, so that explains this right here. Now let me get this out the way so I can. So now you just plug that back in over here, and then we just go on that property that I just showed you earlier. So here we go. What was the property what was the exact numbers I chose? Okay, I guess it doesn't even matter. Plus 4, okay, is the same as 2 to the power of 3 times 2 to the power of 4. So right now we got e to the power 1/2 times e to the power of that blue highlight, which takes us to this step. Now we're going to go backward. We're going to go up here, and we're going to go 3 plus 4, which is 1/2 plus negative this, which is the same, which simplifies basically to that. They just wrote, because they both have a denominator of 2, they just combine it with a denominator of 2 right here. Okay, they made both a denominator of 2. So yeah, let me see if I can write that out. I'm wondering if that can be a little bit confusing for people too. Let me see if my pen works. Okay. You know what? Let me just do it like this. So let's see if my pen is going to work okay. So as of when you plug back in e to the power 1/2, you get this. I'm gonna write right here. Okay, that's a u. Whoops, let me write that a little better. Okay, that's a u right here. When you plug back in c, you get this and e to the power of negative cosine v squared over 2. Now, that we're basically at this step right here. Okay, we want to get to this step over here, so we're going to combine it. We're going to u equals to e to the power of 1 minus cosine v squared, or let me actually write it out a step beforehand. E 1/2, and you can plus negative cosine v squared over 2. And then all they did here is just combine those two to become this right here. Okay, so hopefully that makes sense, folks. Let's scroll down to number 8. Number 8 should be pretty easy. Okay, they multiplied both sides by ds, took the antiderivative, did some u substitutions. You're going to get c sub 1 here, c sub 2 there, subtract c sub 1 from both sides, it just becomes a big fat c. Okay, now let's plug in 0, 1. Okay, excuse me, 0, 0, I believe. Okay, so yeah, 0, 0. So we plug in 0 for r, e to the power, negative 0 is 0, e to the power 0 is 1, slap on a negative. So that explains that, hopefully that explains how this became that. Okay, let me highlight that a little bit. This became that. Okay, 0 times negative 2 is 0, e to the power 0 is 1, negative 1/2 times 1 is just negative 1/2. Okay, and then you isolate for c, you get c equals to negative 1/2. Okay, the hardest part about this problem, in my opinion, is simply the algebra and the property of logs afterwards. Okay, so look, we're going to plug in the negative 1/2, okay, right over here, okay, and hence we get that, okay, and these two just got carried down. Now, how do you isolate for r? That's the key question, okay? So the way you would do it, okay, the way you would do it is like this. Okay, so first of all, we're here after plugging in negative 1/2 for c. What they initially did was multiply everything by negative 1, basically change all the signs. So these, okay, these right here got changed into all positive. Okay, and now what we're going to do is do log of ln of both sides. Okay, so I'm going to take an ln. Okay, I'm going to take an ln of everything here. Okay, ln here, and ln. And then remember, ln of e, okay, ln of e, we did this property yesterday. ln is basically log, okay? So log base e, I mean, ln is log base e of e, okay, to the power of negative r. You can move this to the front so it becomes a big negative r. So this cancels. And log base e of e is just 1 because e to the power of 1 is e. So you get negative r, which is here. Okay, and then on the right side, we get this, we get ln of this. How do we simplify that? I'm going to rewrite, I'm just going to copy down what we have here to here. I'm just going to, this is e to the power negative 2s over 1. So I'm just going to group this in the numerator. And so these both at this point has a denominator of 2, so we can go ahead and combine the fractions. 2, 2, 2. And then I put this 1 right over here, and then put this e to the power negative 2s right here. Okay, so as of right now, we have negative r. Okay, the black negative r equals to this black ln parentheses 1 plus e to the power negative 2s over 2. Okay, never mind my annotations so far. Okay, I'm just focusing on the black to explain this black over here. Now, what happened is, okay, let's get some markings out the way now. Now what happened is that we need to get rid of this negative from the r because we want to isolate r. So I'm going to multiply both sides by negative 1. So r becomes positive, and we have negative 1 times this ln, okay? Remember, -1 over here, property of logs means we can move it to the exponent, okay? And here's an example. 2 over 3 to the power of -1 means you just flip the fraction. So since we can move the -1 coefficient into a fraction, into an exponent of -1, by this same property, we can flip this fraction and get this. And so r equals to ln of this flip fraction, okay? Hopefully that answers number 8, folks. Let's move on to number 9, okay? Number 9. I'm going to make a separate video for number 9 because that's probably going to be a longer one. I don't want to make this video super duper long. Okay, so thanks for tuning in.